In this video, I'm going to give you an example similar to 5.53. So this chapter, we always talk about Bernoulli trials. So when we do an experiment, for example, tossing a coin or asking people questions, every time we toss the coin, it's called a Bernoulli trial. Or every time you ask one person, that's a Bernoulli trial. And notice that when you ask many different people questions, the same question, or when you toss the coin many times, each time is a Bernoulli trial. As long as the people we selected, as long as we select the people randomly, that we guarantee all these their answers are independent of each other. So one person's answer is not going to affect the other person. So we need to remember that. And we learned before that whenever we have, in the previous chapter, we learned that if A and B are independent, the probability of AB, so which means A happens and B happens, and most of the time is like, so if you toss the coin twice, so we have two Bernoulli trials, and this is the first Bernoulli trial A, second Bernoulli trial B, and whatever you get, because they are independent of each other, so the probability of A and B is going to be equal to the probability of A times the probability of B. So we'll keep using this formula. And so let's go back to the problem. It says the Bernoulli trial with success probability P equal to 0.3. So I'm going to change it to 0.2. Well, actually 0.4. So for example, we're going to do, so example for 5.53. So I'm going to change the success probability to 0.4, which means the probability, the failure probability is 1 minus P equals 0.6. Again, because we're talking about Bernoulli trial, there are only two outcomes, either success or failure. So we're going to, of course, the probability of the success and the failure is going to be add up to 1. And so that's why we can find 1 minus P equals 0.6. And next, we're looking at first part A. Find the probability that 4 trials result in failures. So we're going to do 4 trials, and each of them ends up a failure. So that means if I use symbols to represent, use F to represent the failure, So we have part A, which is a failure. The first try is a failure. Second try is a failure, and the third one is, failure, and the last one is a failure. So we're looking for the probability for this event. So it's, instead of having the formula we talk about here, it has only 2 events. These 2 are independent, but we can generalize this to any number of events, as long as they are all independent of each other. So if you have 3 events, A, B, C, C, and then the probability, as long as they are all independent of each other, we call the probability will be the product of all 3 of them individually. And if we have 4 of them, so in this case we have 4 events, each of them has a failure outcome. So when we look for the probability of PFFFF, it's going to be equal to the probability of each F. The first time it's a failure, the second time it's a failure, third time is a failure, and the last time is failure. So the probability of the first failure is let's look at the failure probability is right here, 0.6. It's 0.6, and the second time is still 0.6. It's not going to change. It's not going to be affected by the first time. And the third time, the probability of failure is still 0.6, and the last time the probability of failure is also 0.6. So we multiply all these, you get an answer. Okay, all right, and so actually the answer should be if you use calculator, 0.025, I believe. Okay. Now next, we're going to look at part B. So part B says, given that the first 4 trials result in all failures, and what is the conditional probability that the next 4 trials are all successes? I'm going to change this problem to 3 trials. The first 3 trials result in all failures, and we try to find out the conditional probability that the next 3 trials are all successes. Okay, so let's do this. So first, the first 3 are part B. So we're looking for the probability, P to represent the probability of 3 successes. Success, given the condition that the first 3 were failures. F. So be careful, this is different from, this is not the same as P. So the first 3 failures and the next 3 successes, they're not the same thing. If we, this means the probability of FFF, but this one is still looking for the probability of SSS. But given the condition that this has already happened, the first 3 trials were failures, so they're not the same thing. Well, so we are the conditional probability. We have a formula before, which is equal to. In fact, in this case, we don't really need to use that formula because these 2 events are independent. Again, even if the first 3 trials were failures, they're not going to affect the results of the next 3 trials. So the conditional probability is going to be the same as, it's like the first 3 trials didn't happen. So if we're looking for the probability of 3 successes, it's going to be the same as that. Okay, so notice that this is totally different from that. Okay, and well, this one is looking for we need to guarantee, we want to find out the first 3 failures and the next 3. So we're talking about the probability of these 6 events, the intersection of these 6 events. But over here, we only talk about the probability of the 3 successes. Okay, and this is going to be similar to part A. So we're trying to use the formula because each trial is independent of each other. So we multiply the probability of these 3, and the probability of success, and success. So you multiply them. 0.064. Okay, so that's part B. Now part C says that find the probability that the first success occurs in the 4th trial. So again, this question is saying that you did 4 trials. So you like tossing a coin or ask people questions, and you asking 4 people, or you toss coin. You're going to toss coin 4 times, and the first success occurs in the 4th trial, which pretty much means the first 3 were failures. So failures. So it's like F, and S. Okay, I'm going to change maybe the problem to 3 trials, and the first success occurs in the 3rd trial, which is similar to this. So let's do this. Okay, so if I move the page down a little bit, do part C. Okay, if we do part C, so we do 3 trials, and the first success occurs on the third on the third. Okay, so and we're going to write down, use the symbols to describe it. So the first success occurs on the third trial, which means the first is a failure, the second is a failure, but the third one is success. Okay, be careful. My example only has 3 trials. In the homework, you have 4 trials, so you need to have four letters to describe it. So find the probability of PFFS. And so we use F, which is probability. So this is going to be the probability of F times probability of F times probability of S, and that's equal to probability of F. That's failure. It's 0.6 right here. So do 0.6 times another failure, 0.6, and the third one success, 0.4. So we multiply them and we get the answer. Okay, so these questions you don't, some of them you can use binomial distribution formula, but really you don't have to, because in each of these cases we have a specific answer for each one. Like the first one is, we know if it's a failure or success. The second trial, we know if it's a success or a failure. And when do we use binomial trial formula, binomial distribution formula? When we don't know which one is success, which one is a failure. We only know, like say we did 4 trials, we only know 2 of them were successes. We care about 2 of them are successes, or we care about if 1 of them is a success, or 3 of them, which we don't know. We don't care which one is success, which one is a failure. In that case, you will use binomial distribution formula.